All right, students, let's look at example 3. In example 3, we're talking about students who have taken maths and econs exam. All right, so we define in part 1, we are asked to find percentage of students who pass at least one subject. So we first define a student who passed maths as event A, and we define a student who passed econs as event B. All right, there's one thing that you will need to take note. In this case, the the probability of a student passing maths is given in terms of percentage in a question, which is in this case 75%. So you will need to know how to convert from percentage to probability. All right, you just divide by 100. So 75% divided by 75 divided by 100 will be 0.75. So that's how you get probability that a student pass maths, or probability of event A is 0.75. Likewise, you do the same for PB, which is probability that a student pass econs. So you use 70%, so 70 divided by 100 to get 0.7. Probability of 0.7 for PB. All right, and probability A intercept B is 0.6 because there's 60%, you're told 60% of the student pass both maths and econs. So probability A intercept B, that means pass both maths and econs, is 0.6. All right, so let's look back at part 1, percentage of students who pass at least one subject. So first of all, you have to find the probability of a student passing at least one subject. So it will be probability of A union B. All right. So let's recall, how do we find probability of A union B? So that will be PA plus PB minus P minus P A intercept B. All right. So PA is, in this case, all the values are given already in the question. So P is, you know what is PA, you know what is PB, you know what is PA intercept B. So you can get probability A union B is 0.85, but the question asks for not probability but percentage of students. Okay, so therefore you need to convert from probability back to percentage. So you just times 100 to the probability. So it will give you 85%. So 85% of the students pass at least one of the two subjects. All right, let's move on to part 2. Part 2 is finding percentage of students who have passed exactly one of the two subjects. That means either just pass maths or just pass econs. All right. So in terms of the Venn diagram, where will it look like? So that means it will be here and here. All right, so the shaded region will be where the student pass exactly one of two subjects. We exclude the middle part, the intersecting part of A and B, because that will be where the student pass both subjects. That's not what we want. All right. So how do we obtain this? So this part in this case would be probability of A intersect B prime. All right. So that means it's in A and not in B. And this part will be probability of in B and not in A, or probability of B intersect A prime. All right. So that's here. Okay. So that's why the Venn diagram is very useful. Okay. So once you have this, you can see what's the probability. Okay. So we know that okay, so A intercept B, so this is 0.6, and P is 0.75, so therefore this part will be 0.15. And PB, the whole thing is 0.7, so 0.7 minus 0.6, so this part will be, all right, so this part would be 0. Probability of 0.1. All right, over here, it will give us a probability of 0.1. Okay, because it is 0.7 minus 0.6, so that will be 0.1. So therefore, when we add both of them together, you'll get 0.25, probability of 0.25. In terms of percentage, there will be 25% of the students that pass exactly one of the two subjects. All right, part 3. Find a probability that a student fail both subjects. All right. a student fail both subjects. So if a student fail both subjects, that means we are finding probability of A prime intersect B prime. That means not in A and not in B. All right. So okay, let's look at this thing. Okay, so this will be equals to 1 minus probability A union B. All right. So probability A union B, we have already obtained it in part 1, which is 0.85. So we can calculate, easily work out the required probability will be 0.15. And part 3 asks for probability. So that's the answer already. We do not need to convert to percentage for part 3. All right, let's move on to example 4. Okay, so in example 4, it talks about in a race in which there are no ties. All right, so do take note. We are talking about the question is talking about situation where there are no ties. That means there's each time there's only one winner. All right, probability that John wins is 0.3, probability Paul wins is 0.2, and probability that Mark wins is 0.4. What probability that John or Mark wins? All right, so probability John or Mark wins, so that would be equivalent. So let's say if we define John wins as J and Mark wins as M, and yeah, so then yes, and Paul wins as P, right? Then probability and all will be union. So we call probability J union M is actually probability J plus probability M minus probability J intersect M. But in this case, because the question say that in this race there are no ties. So therefore, probability of J intersect M, what does it mean? That means John win and Mark win. It's never possible because there's no tie. So this probability will be 0. So that's why for part A, it's just Pj plus Pm. So it works out to be 0.3 plus 0.4, right? So that's how you get the answer 0.7. Okay, part B, find a probability that John or Paul or Mark win. So in this case, it's just since so likewise, there cannot be a situation where more than one person win at any one time. So therefore, we just add up all of them, right? So each of the probability 0.3 plus 0.2 plus 0.4 to get the answer for part B. All right, for part C, find a probability that someone else wins. Someone else wins. So in this case, so you will someone else wins. That means the winner is not John, and it's neither John nor Paul nor Mark. So therefore, we will use the total probability, which is 1 minus away the total probability of either John or Paul or Mark wins, which is the answer from part B. So 1 minus the answer of part B, so you get 0.1 as the answer to part C. Okay, good. Now, let's move on to exercise 1. All right, to look at a few questions pertaining to what you have learned so far. In exercise 1, question 1, talk about two events, C and D, and you're given a probability of PC, probability of complement of D, and probability C union D. You're asked to find probability C intersect D. All right, so you have to look at what are the information you're given and ask yourself any laws or any rules which relates what the information that you're given with what you need to find. All right, so okay, we know that probability of D is 2/5 because probability of D is 1 minus probability of D prime. All right, so and you're given probability of D prime. So now the thing that relates C intersect D with C union D will be this one, will be this rule. All right. So probability of C union D is PC plus PD minus P probability of C intersect D. So we want to find this one. This is what we don't know. And PC we have, PD we have just worked out, and PC union D is we also have is given a question. So with some manipulation by making probability of C intersect D the subject of this equation, we'll be able to work out and find what we want. All right, so that will be the answer to question 1. Good. Let's move on and look at question 2. For question 2, you are told in the sample space S, denoted by S, is given that PA is this, PA union B is this, and PA intersect B is this. So part 1, you're asked to find PB. So again, what is relating A union B and A intersect B will be the same rule or same law as the one that we have used in question 1. So PA union B is PA plus PB minus PA intersect B. So what do we know? We know PA and we know PA union B, and we also know what is PA intercept B. So the only unknown is PB, so we can easily find from this rule or this law. All right, what is PB? Okay, part 2, probability of A prime intersect B. So that means it is in layman's terms is we want in all right. Okay, so in B and not in A. So okay, so we can use the strategy of drawing a Venn diagram, and then we put down all this probability. So P is 0.5 and A intercept B is 0.2. So this part will be 0.5 minus 0.2, which is 0.3. And this part it will be in B and not in A will be PB minus PA intercept B, which is 0.3 minus 0.2, so this is 0.1. So in total, this adds out to be A union B adds out to be 0.6. So this part, which is outside the two circles, will be 1 minus 0.6, which is 0.4. Okay, so after we have set the stage for all these, work out all these values and represent them on a Venn diagram. So now back to part 2, we want B intersect A prime. That means in B and not in A. So where is it? So it's in B and not in A. So it will be PB minus P A intersect B. So it's 0.3 minus 0.2. So it's 0.1. All right. So part 3, probability of A intersect B prime. That means in A and not in B. So if this is what we want, okay, let's shape the required region for part C. In A and not in B. So this is what we want, all right, in A and not in B. So it will be PA minus P intercept B, so it will be 0.5 minus 0.2, so it's 0.3. Okay, part 4, probability A prime intercept B prime. So A prime intercept B prime, okay, so this is the same as A union B, the whole thing complement, right? And this would then be equals, we can see that this can be written as 1 minus probability A union B. And probability A union B is already given a question, 0.6. So it's 1 minus 0.6, so it's 0.4. All right, so that's the answer as well as the method, how we can work out part 4. Quite straightforward and especially useful and clear after we have sketched the Venn diagram as well as represent the various, work out the various probability for the various region. Good. Let's move on to the last question in this exercise, which is question 3. In question 3, you're told in the survey, 15% of the participants said they had never bought lottery tickets or premium bonds, 73% had bought lottery tickets, and 49% had bought premium bonds. So far, probability that if you choose a participant at random, this participant had bought lottery tickets or premium bonds or both. All right, so let's say again we can define event L as the participant had bought lottery tickets, all right, and P as the participant had bought premium bonds. All right, so then in this case, we want to find part A, probability that a had participant had bought lottery tickets or premium bonds or both. So what does it mean? All right. So this would mean probability L union B, right? So this is the So in terms of set notation wise, this will be the set notation. Probability L union B. Alright, so how do we work this out? So this will be equals to 1 minus probability of, that means this particular participant have never bought lottery tickets or premium bond. Alright, so that means it is L prime intersect B. Okay. So in this case, you will use the total probability, which is 1 minus probability of L prime intersect B prime. So that means this participant have never bought lottery tickets and never bought premium bonds. Alright, so that will be 0.15. Okay, part B. The probability a participant have bought lottery tickets and premium bond. So in this case, and in part B, so that would means probability L intersect P. Alright, so probability L intersect P will be equals to P probability L plus probability P minus probability L union P. Right, so this is from the manipulation of the law of probability. So in this case, PL, we know that it is 0.73. Probability of P, that means probability that participant have bought premium bond is 0.49, and probability L union P. So that means this is the answer to part A. So that means participant have bought lottery ticket or premium bond or both. So it's 0.85. So that's how we get the answer for part B. Alright, part C. Find a probability a participant have bought lottery tickets only. Okay, so if the participant had bought lottery tickets only, then in terms of the Venn diagram, let's see how will it look like. So this will be the sample space, and this will be L, and this will be P. So for part C, if the participant had bought lottery tickets only, so that means we are just looking at this part. Alright, so to find this part, how are we going to work this out? So that means it will be probability PL minus away PL intersect P. Alright, so PL is 0.73 and PL intersect P. So that is the answer for part B. So that's how you get the answer for part C. Alright, so the required shaded region is as shown in this Venn diagram. So therefore, you can see that these few questions in this exercise serve to illustrate that the Venn diagram is a useful tool to help you to solve some of the probability questions. Okay, good.